All right, so we have made it to the end of the key features. Woo! Woo! Yeah, 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 yeah. All right, so we are doing all of this part, and so we have gotten to the end of doing x and y intercepts. We actually did intervals of increasing, decreasing, constant, positive and negative, and we just talked about max and mins, max, relative mins, and all that great stuff. So the very last part, as I actually think is the easiest part, we're going to do with end behaviors. Like what in the world is happening at the ends of the function? Like what in the world is happening there? That's what we have to figure out. That's what we're going to that's what we're going to do. So with that, as we're talking about end behavior and asking like what's happening at the ends of the graph, this is what we're going to end up doing. So we're going to be asking this, and you might be like, I know infinity, I know what x is and what y is, but what's that arrow mean? I don't know. 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 All right, so with that, here's what it means. As x approaches infinity, what does y go to? What does it approach? So as x's get going from to the right side, because we know when we talks about our infinities here, we know on the number line here, positive infinities on this side because all the positive numbers are over there. So as x is going this way, like what is happening with your y? Is it going up? Is it going down? Is it going to positive infinity? Going to negative infinity? Is it going to a number? What is happening to the graph? What is y? What is y doing? Is it going? Is it randomly going somewhere? We don't know. We got to figure that out. All right. Then also, they're not only going to ask us what's happening when it goes to the right. Sorry. They're also going to ask us as x approaches negative infinity. So again, the arrow means approaches. So as x approaches infinity, as x approaches negative infinity. And you know what? As y approaches this number, as x approaches this, y approaches this. That's what we're trying to find out. And so that's what it says right there too in word form. As x approaches negative infinity, what does y go to? What does it y approach? What number does it go to? Does it go to infinity? Does it go to negative infinity? Does it go up forever? Does it go down forever? Up forever meaning positive infinity. Going down forever, negative infinity. What is happening? What? All right. So let's take a look at that. And we're going to take a look at let me do this part too. So we talked about how it went to the right here for the positive infinity. This way would be negative infinity here. And as it's going to the left, what's happening? What's happening to your y? Is it going up? Is it going down? What is happening? Oh, we got to find that out. All right, so with that, hopefully in Math 3, you guys learned about how to tell what's happening at the end of the graphs by just knowing if it's even, odd, what's going on with that part, and how the functions go. Are they going up, they're going down, and ever transformations and all the good stuff. So with this, first off, you should know, because this is an odd exponent, that it's going to do something that looks like, let me do a pencil, something that looks like this. Oh, sorry, you can't even see that. So something that looks like this, because it's an odd number. If it was even, it would go like the same direction. So again, this is odd. This is even exponent. The even exponent there for you. So with that, if it's an odd exponent for the leading coefficient, it's going to go in opposite directions. If it's even, it goes in the same direction. So with that, the only other thing that's happening here is we actually have a negative in front, and we're going to talk about this when it comes to the next lesson about transformations, or 2 lessons from now. When it comes about transformations, it means it's going to flip it. So just looking at it here, get that out the way, don't need that. So when so it's going to flip because of this negative right here. So I'm going through this, but we're also going to graph it out too, so you can see that. So it should flip this way, because it's an odd exponent. It's going to go in opposite directions, and it should flip this way. But let's go ahead and go into to Desmos and actually check and see if it does do that. All right, so we have the equation there, and so that's going to put this in to Desmos. Oh, no, 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 no. Don't need that box right there. No. There we go. And then plus 2x. All right, so we have this wonderful graph going on. And like we said, it should actually look like it's going up on the left side and going down on the right side because of the transformations and everything. And if we look at it, let's go and get rid of this keyboard right here. And if you look at it, let's zoom out too so we can kind of see. We were right. We were right. So it's going up here on the left side and going down on the right because of the transformations and all the good stuff. So again, odd functions actually do the opposite directions. So one goes up, one goes down. If it's even, they go in the same direction. Okay, so with that, let's go ahead and talk about it and see what's going on. So with that, let me go and pull back up the Elmo. Put this off to the side a little bit. So, and let me zoom in so you guys can see it even better. All right, so here we're talking about what's happening on the ends, the end behavior. So what's going on the ends of the function. So x is approaches positive infinity, and as x is approaching negative infinity, we're trying to figure out what is happening with our y. Where is it going? To go into positive infinity, go negative infinity. What is happening? So with that, we said again, when it comes to your positive infinity, that means we're looking at going to the left side of the graph. So as we're going this direction here, what is happening with your graph? Is it going down to negative infinity? Is it going up to positive infinity? Is it going to a number? So, oh, sorry, here you go. Now you can see it. Once we're going over to the right, what's happening? So with that, we've looked at this problem here, and we're looking at going from, let's say, from 0 and going over to negative, positive infinity on the right side here. It's going down, and there's no way that it's coming back up because it's constantly going down, and you can see there it continues to go down, down, down. It's going down, 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 down. Now with that, our y values are here. As it's going down, it never stops because it just goes on forever, and no matter where you go. And let's take a look at it too. Let's explore that. All right, so we're at negative 200. Stop it. There we go. Negative 500, negative. Okay, it goes on, goes on. We're at negative 2,000 plus, negative 4,000, and it has not stopped. So that means it must be going to infinity because it has not stopped at all. So with that, as x is going to positive infinity, and let's go ahead and pull this back up in Elmo again so you guys can see it. So as x is approaching positive infinity, going to the right, sorry, your graph is going down forever, does not stop. And negative infinity is at the bottom. Wherever that last number is going to be, it's going to be negative infinity. The negative numbers, the negative part down there. All right, and then as you looked, hopefully you saw it also. Just really quick, go back. Oh, sorry, wrong way. If you're going to the right, going to the left, sorry, and going to negative infinity, so going this direction. As we're going this direction, the graph continues to go up and 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 up, and that line doesn't stop. And we're positive 500,000, and it's still going. You can still see that red line right there. So with that, if you can still see that red line, that means that it's going on forever and ever and ever. So it means it's going to infinity also. So here, let's go ahead and pull this back in. So as x approaches negative infinity, your y is going to go to positive infinity. It's going to go up forever and ever and ever. It does not stop. And as you can see, it doesn't stop. It just goes and goes and goes. So cool. That's what they're looking for. When x is approaching infinity, going to the left, going to the right, tell them what's happening with y. As x is approaching negative infinity, tell them what's going on the left. What's going with your y. All right, so we have one more that we're going to take a look at really quick. The end behavior. And again, with this part here, this is the last question, the next example and everything. We're done, guys. We're done. All right. So here, before we actually move anything through or do anything, I'm going to move things around so that we have descending order with exponents. So here, the highest exponent is x to the 8th. That's x to the 7th, and then the third power. So we have this going on. So we're going to put it in descending order. And so when we look at this, we say, okay, that's the 8th power. That's the highest exponent. It's even. So if it's even, an even exponent, that means that it's going to go the same direction. So the end behavior is going to go the same way. So it could go up or it could go down depending on what's going on up top in the front, sorry. So if it's even, it goes the same direction. But with this negative, it means it's going to flip. And again, when we go through transformations later on, we're going to talk about that more. So normally it would go up, but this one should have it going down. Again, let's go ahead and check that out really quick. Let's put that in the Desmos. So let's exit you out and let's put the new one in here real quick. Really quick. And even if you put it in, I'm going to put it in the way that we've just rewrote it. But even if you put it in the original way, it's still going to work the exact same way. It's still going to give you the exact same answer. Plus 5x cubed. All right, and then we get this. And because we've zoomed in so much on the last problem that we did, we're going to come and zoom back in and see what's happening. Let's go. Oh. Is that what we said was going to happen? That's exactly what we said. We said we're going to go down. We said it was going to go down forever and ever and ever on both sides. And bam, we said it was going to be that one. And look at it, did it. It did it. It's going down here. It's going down on this side. Yes, sir. Yes, sir. We got this. All right, so it's going down forever on both of them. So as x approaches positive infinity and x approaches negative infinity, what is our y doing? What is it approaching? What is it going closer to? On the right side, this is going to positive infinity over here. It's going down forever. Forever. And as you saw earlier, it was like all these signs, and you can still see that blue line down there. So it is not stopping. It's not going anywhere. There's nothing that's going to keep it from going on forever and ever and ever. So down is negative, so that means we're going to negative infinity. And the same thing is happening on the right side. As it's going to negative infinity on this side over here, it's still going down forever. So it's still going to negative infinity. And so that's the process we're looking at every single time. As it's going to the right, what is happening with the graph? Is it going down? Is it going up? Is it going to a number? And then when it comes to the left side with negative infinity, where is it going? Is it going up, down? And then you tell me if it's infinities or not. And 9 times out of 10, we're going to go to an infinity. So we could go to a number sometimes, but 9 times out of 10, it goes to infinity. All right, so guys, that is it. We have finished. Yes. Woo!